I guess it's the old thing of what do you call the first clear night in 4 weeks? It's meeting night. Everybody seen Venus tonight? That's the first thing I've seen in a while, and the moon, of course. Oh well, it's February. And another month and it'll start to get a lot warmer. Yay. Tonight, what's new with Jim Fairless? Jim, unfortunately, I think some of you may know his wife was in hospital and he was picking her up today, and I just got an email that he won't be able to attend tonight. I'm not sure if his wife needs him or if there's been a problem, but his wife is in hospital, so that's not a good thing. So he won't be able to do it, but I will do it in his place. Substitute, second string, as they say. I'd like to talk a little bit, well, damn. I have to put a slide in for that one. Anyway, I'll tell you about that one. And Rocky, after the break, Rocky's going to talk about Ptolemy's contraption. We'll do some announcements, 50-50 draw, and then we'll head to Hoover's basement. We're going to start off with the What's New. And following the What's New, we're going to get Peter and Brian and whoever else wants to get involved. And we'll talk about a few new things in telescope. All right. In astronomy news, how many have seen this picture? Yes, it's a beauty. It's now the sharpest they've ever seen the surface of the sun. It's a brand new telescope called the Daniel K. Inouye. Is that how you pronounce that? I believe he was a senator from Hawaii, if I'm not mistaken, in World War II vet. I believe he was of Japanese descent, and he fought in Italy, a Medal of Honor winner. Quite a fellow. But they've named a new solar telescope after him. A new telescope in Hawaii has taken its first photo and movie of the sun. The shots are the highest resolution views of our star yet, showing details on the sun's surface as small as about 18 miles in size. So that's what we're looking at. Just to let me go back a bit. I wanted something. It doesn't come out here. One thing I was surprised to put. Why isn't this working? Okay. Interesting stat. Each of those little individual cells is about the size of France. Oh my. And I didn't realize on these, but these are coming up. These are above the background, and this is the background. So it's hard to picture that in 3 dimensions, but if I'm understanding it correctly, please, anybody's got a better handle on this, I believe that's the case. That the darker areas are raised up above the surface, and the background is what were the bright areas. Okay, the Daniel K. Inouye Solar Telescope was located on the Haleakala volcano on the island of Maui. That's a great spot to go to. You don't have to go to 14,000 feet and risk drowning in your own lung secretions, but Maui is at 10,000 feet. The observatories are at 10,000 feet, and it is quite a spot. There's a big parking lot. Once you've paid for the admission to the Haleakala National Park, which includes all the summit, you can stay there. I think it used to be you could stay all night. Now I think it's 2 in the morning, and you need another pass to stay from 2 in the morning until I think it's 6 or 7 a.m. whenever it is.
Steve,
yeah, go ahead, Simon.
Yeah, there is one group now that take tours up there with a telescope. Who actually go, they'll drive you up in a minibus as well, so you don't have to
Excellent.
worry about coming back down again.
Okay.
And they actually get a telescope up there, they set it up for you, and provide hot drinks and well, so really good.
I had one of the highlights of my life on Maui. We had rented a convertible. We went in there, we had reserved the cheapest, this is good advice for everyone, the cheapest rental car we could. And of course, when we got there, they were all gone. So they gave us one of the upscale ones for the same price. convertible. And we went up Haleakala. There's a big winding road going up, and then you drive. And every time you're down below and you look up, you think, oh, the whole summit must be raining and cloudy and really nasty up there, because just all around the volcano, as the trade winds go up, they are pushed up the mountain, they condense, form clouds, and it's usually raining or at least misting all the way up there. But then you drive out of it, and then all of a sudden, next couple of thousand feet vertical, you're out of the clouds, and you're looking down in the clouds, and sometimes all you can see is clouds in all directions, if it's overcast at the bottom, but it's clear at the top. But the Pan-STARRS Observatory is up there, which takes, I think the initial plan was to take 2 pictures a week of, cover the entire sky visible from that area. It's a wide field telescope, and takes about a 30-second image, I think it is. Takes it to something like magnitude 22 stars or something, but it's looking for near-Earth objects primarily, and it doesn't keep the pictures, it just sends the data down a fiber optic cable down the hill to their computer, and they just update that image, and it automatically looks to see if anything's moved since it's set up its data set on where all the objects are. And that works out pretty well. They found a lot of stuff and a lot of comets. Anytime you see a Pan-STARRS comet, that's where they found that. But if you do go up there, the new solar telescope is up there. It's a great spot, by the way, for if you do go up there. My wife and I were out there. She's not that much into astronomy, but she was blown away. At that time, it was moonless when we were up, and the Milky Way was pretty much right up at here. This is southern. It's 22 degrees higher than you are here. And when you're standing there in the parking lot, you can see your shadow on the parking lot from the Milky Way. It's an astounding thing to see. It's just so incredibly bright once you're used to it. Primary mirror on the solar telescope is 4 meters wide, making it the biggest solar telescope on Earth, and it will be able to resolve smaller details on the sun than ever before. With the telescope's sophisticated instruments and high resolution, scientists hope to better understand remaining mysteries about our nearest star. And there's reasons to want to know what's with our star, because from time to time it throws out stuff. Every few centuries it seems to throw out stuff that would probably end our technological civilization. So the more we can be able to predict that, the better off we're going to be. So all that stuff is great. This is the Parker Solar Probe, a spacecraft launched in 2018 on a mission to explore the sun's outer layers. It is already revealing new insights about our star. Now scientists have translated some of the probe's measurements into funky sound clips that you can listen to on their SoundCloud page or in the embedded video above. Well, I don't know that we'll be able to get this. It looks like a YouTube. I don't know if it's embedded or not. I got the call this afternoon, and I'm not a wizard at this stuff, so I wasn't able to get too much going. But okay. I'm sorry we can't you do that one, but if you go to YouTube, you'll hear the sounds. It's pretty good. The various different kinds of solar activity generates various different sounds, and it's quite interesting. Talking about Betelgeuse, it's now dropped down. I think it's 34 places in the rankings. Well, 34% of its usual brightness. Anyway, it's really dropped. It's not ranked, it's not a first magnitude star anymore. One of the brightest stars in the sky is dimming. Could it be on the verge of a supernova? Betelgeuse has created a sense of suspense in the astronomy world, which is hoping to someday observe a nearby supernova in real time. I don't know how much you folks are into supernova, but the first we'll know about it will probably be neutrino detections on Earth. The first thing that happens in a star that big is that the iron core collapses and into a neutron star, and all of the electrons and protons and neutrons are jammed together, touching each other. And of course, electrons and protons can't touch each other. They annihilate something. Some of the mass gets converted into energy, and neutrinos. So you get a big neutrino pulse, and even though individual neutrinos can go through a light year of lead, and only have a 50-50 chance of interacting with anything. In this particular case, there's so many of them released that even a tank of fluid, let's call it that, for neutrino indication, they still capture usually several of them from a supernova. So there's one hell of a lot of neutrinos come streaming out of Betelgeuse, and that's quite a bit, probably approaching an hour before the eruption breaks the surface and the brightness changes. So we're looking, but maybe not yet. It seems that most the things I've been reading indicate that it's probably puffed out a lot of gas, which is then cooled down and is now basically acting as a cloud and blocking the light from the star. It may be thousands of years before Betelgeuse actually blows, but the reality is we don't know enough about what's going on to know that for a fact. So we'll just keep observing. The story on this keeps getting worse. Yeah, there's another, now the OneWeb or something has now launched a whole dozens of satellites, the same idea as Elon Musk's, so I don't know where that's going. Elon Musk's plan for worldwide internet has sent bright artificial light streaking through the dark. These satellites have turned out to be far more reflective than anyone, even SpaceX engineers, I don't know if they cared, expected. Before Starlink, there were about 200 objects in orbit around Earth that could be seen with the unaided eye. Certainly before these went up, I know we could sit out at Tilkers or wherever and you could see in the satellites going through overhead. There was about 200 of them you could see with the naked eye. But we've already, SpaceX has already added another 240, and I believe that number may have grown since then, but certainly every few weeks they send up another 60. These are brighter than probably 99% of existing objects in the Earth orbit right now, said Pat Seitzer, Professor Emeritus at the University of Michigan, who studies orbital debris. And there's more going up from other vendors.
Do they have to do anything to bring them back down at end of life? Or are they off the hook?
Well, technically they're still in the outer fringes of the Earth's atmosphere. So, I mean, there's some drag, and over time they will be brought down, but it's going to be decades. In 1,000 years they'll probably all be down, but until that time. I believe they do have to have some kind of, I'm sure there's other folks here who are far more knowledgeable on spacecraft than I am, but I thought they had to be able to deorbit these probes in order to send them up. Dave?
Yeah, they do have an engine on them.
Okay.
And in fact, they use that for dodging debris. And once there's a certain amount of a fuel level has dropped to a certain amount, they will actually deorbit them. It's not a very big drop to start hitting the atmosphere, and then from there on, it's a matter of weeks until they re-enter and burn up. So a couple of them from the first launch, I think 3 of them didn't actually make their final orbit, so they're coming down by themselves. I think one of them failed completely and is going to come down in a couple of months, and 2 of them they just figured they didn't need, so they're just deorbiting them immediately.
Oh, big
I think they said they're like 200 kilograms a piece. Wow. Something like that. They're fairly heavy.
But small, I would think.
But fairly small,
A couple of feet in
they're
diameter, something like that.
obviously packed. And they just have a solar panel that extends out from one side. So hopefully they're not going to be quite as reflective that way as the iridiums were.
Are the rockets on them such that they give them enough control so that when they come down, they can come right down on Elon Musk?
I think he's got something in the program that avoids that.
Hackers take note. So here's a astronomers observe burst of activity as a massive star forms. Okay. Massive stars influence the structure, shape, and chemical content of a galaxy. And when they have exhausted their hydrogen gas, fuel, and dye, they do so in an explosive event called a supernova. This explosion is sometimes so strong that it triggers the formation of new stars out of materials in the dead star's surroundings. It's blowing off all of these new elements it's synthesized, and they enrich the clouds that new stars are made from. And for the most part, stars don't need the heavier elements, but Earth-like planets do. Unless you've got silica and oxygen, you're not going to get most rocks. So silicon rather than oxygen. On January 30th, NASA's Spitzer Space Telescope concluded 16 years of infrared observations that allowed scientists to reveal some of the most hidden regions of our universe. With a primary mission of only 2.5 years, Spitzer's 2.5 years. Spitzer's small size and efficiencies propelled the telescope to exceed scientists' expectations, revolutionizing our understanding of exoplanets, the composition of planetary systems, and even the earliest star formations. Ooh. That's the Helix Nebula. One of the few dead star systems where comet survivors are found. These remains are located 700 light years away and are part of a class of objects called planetary nebulae, leftovers of stars that once resembled the sun. They're about the same size of mass, same mass as the sun, roughly. They form planetary nebula. They don't go to supernova. From Spitzer's infrared view, the white dwarf is seen as a tiny white dot in the middle of the picture. Spitzer also discovered a dusty disk, the bright red circle in the center, which was probably gathered by comets after the death of the star. Let's go back. There's a lot of comets in that. It's obviously much bigger than our solar system would be. So the comets are not all the way out to the edge. Okay, Spitzer also discovered a dusty disk, a bright red circle in the center, which was probably gathered by comets after the death of their star. This is the Spitzer image of Messier 104. Both Spitzer and Hubble worked together to create this image of Messier 104, also known as the Sombrero Galaxy. But with only Spitzer's infrared view, the galaxy, 28 million light years away, looks less like a sombrero and more like a bullseye. Using Spitzer, scientists were able to observe a bright, smooth ring of dust in the red. Also, Spitzer detected infrared emission from both the ring and the center of the galaxy, where a black hole lives. Data suggests that the black hole is perhaps 1 billion times bigger than our sun. And this is Christine Koch. After 328 days in space, extensive tests await her. On-the-ground challenges will help Her on-the-ground challenges will help prepare the way for astronauts to travel to Mars. This long endurance weightlessness and how you can ward off the apparently pretty serious side effects of prolonged weightlessness. What Koch and her crewmates will feel when they again enter the Earth's gravity is significant disorientation of their vestibular system, whatever that. The sensors inside our ears that tell us which way is up, and a gravity-induced rush of blood away from their heads to their toes. Tulchovsky said that at the top of the list are tests focusing on vertebral health. Spines can stretch as much as 3 inches in microgravity. And cardiovascular function, particularly how the heart is responding to gravity, These tests are time sensitive because the heart and spine will quickly adapt back to gravity, with the spine returning to its original length. I was reading one article that was talking about the flow of blood in one of the major arteries apparently reverses in people who are in prolonged weightlessness in 0G. That sounds pretty alarming. And Voyager 2, launched in 1976. So it had a glitch. It shut itself down. Voyager 2 is taking the measure of its exotic surroundings once again. On January 25th, the Venerable probe, which has been exploring interstellar space since November 2018, what they mean is it's gone out beyond the edge of the solar system, failed to execute a spin maneuver as intended. As a result, 2 onboard systems remained on longer than planned, sucking up so much energy that Voyager 2 automatically shut off its science instruments. Mission operators report that Voyager 2 continues to be stable and that communications between Earth and the spacecraft are good, agency officials wrote in a mission update yesterday. The spacecraft has resumed taking science data, and the science teams are now evaluating the health of the instruments following their brief shut-off. And there, we'll look at interstellar space, I guess. Thank you. That's that one. I wanted to, any questions on any of that so far?